So this session is all about naming compounds. I decided to do that one separately because it is long and the systematic nomenclature, this system does take a while to. I'm going to take a step back from what we did on Wednesday and start with naming ions. So I know you guys already took your common ion test. This part is understanding how to name ions is very to understanding how to name compounds. So if you look over your chapter, they don't cover naming ions because let's assume that you know that going into that very quickly. I won't go over every ion, but I'll go over how we name ions, give a couple of examples, and then go over how we name compounds, okay? So in naming ions, we start with, let me see, I need to have my periodic table right here so I can look at them. I'm going to start with the simplest ions, right? The simplest ions are the monoatomic ions. So like it says here, monoatomic. Monoatomic, these are the simplest ions. These are the ions made from one element, right? So ions, remember ions means they have a charged species from element. So in naming ions from one element, I'm going to start with the simpler one just to kind of warm up, and that will be the order I go. Okay. The simplest ones are the cations. The cations, so I'm trying to develop some kind of order. I will start with the element symbol, and then we'll go to element name. And then from element name, I'll go to ion symbol, and then ion name. Okay, so that will be the order as we learn how to name. Now, you guys have already learned this before. This is more like a review. Okay, so this is my order, starting with the cations. Once again, I will not go over every cation possible. I'll just go over the more common ones. So I'm going to pick the ions based on what we have in periodic table. Let's see. I'll pick group 1 element, lithium. I'm just going to pick 5 of each. So lithium, we got sodium. Okay, let me go to group 2, calcium. And then group 3. Sorry, I'm supposed to be doing the symbol, right? I'm just copying this and I'm not even paying attention. Okay, my bad, y'all. Calcium, and then aluminum. So symbol first, right? And then let's see. I'm starting with the cations first. So I guess that's it. Oh, this is 4. So let me actually go ahead and do calcium and magnesium and then aluminum. My goal was to do 5, right? 5%. Okay, so let's see. Since I'm kind of making this up as I go, I have to kind of remind myself of what I'm doing. Okay, so these are the elemental symbols. What is their regular name? Their regular name of the element is lithium, sodium, and remember, these cations are mostly metals. So I'm going to write here cations. These are mostly metals. And this is true about 95% of the time. Okay, so I got lithium, I got sodium, I got calcium, I got magnesium, and I got aluminum. Okay, so these are my 5 selected, the ones that made the cut. Okay, when it comes to the ion symbols, since I said back here, these are monoatomic ions. For the monoatomic ions, you find the symbol of the ion or the charge of the ion from the group number. The group number helps the charge. Okay, so charge number. So if you have a periodic table in front of you, which I do, I'm holding it right now, y'all can't see me, but I have it printed out because I need this as part of my job. I periodic table and calculator, so I all the time. Lithium is in group 1, right? So it will have a charge of +1. Sodium also in group 1. It will have a charge of +1. Calcium is in group 2, so it has a charge of +2, right? So I'm writing the ion symbol 2, it will have a charge of +2. Aluminum is in group 3, it will have a charge of +3, right? Usually, ion we have is aluminum. That's the most popular one you see all the time. Okay, now we have to name the ion. So with the metals, the element name is the same as, oh no, why is it saying reload session? Something happened. Can y'all still hear me? What does this mean? Okay, I have no idea what it means by reload session. And y'all can see everything, right? So I hope everything is okay. Anyways, yeah, so now that we have the ions, the element name essentially is the same name used. Oh, you can't see the screen. Okay, I see. Sorry, guys. This is the struggles of Blackboard. You see why I usually need you guys here when I'm doing any recording? Because sometimes things happen and I have no idea what's happening on y'all's end. So I do apologize on behalf of Blackboard. Hopefully, can you see my screen now? I don't know what that was about. Okay, thank you. Yeah, we are in this together. I really do need you guys for this to be good. Okay, so when it comes to the cations, the metals, you use the same name for the ion. Okay, now what some books use, they add the word ion to tell the person reading you're now looking at the ion, not the element. Okay, so some people will just use the term ion, or they don't. But either one, the context will define which one is being used. So you can just use lithium or lithium ion. Either one is correct. Okay. Now, in your common ion test, if you went ahead and put the word ion in it, I had to manually grade because that wasn't one of the possible answer choices. So if you saw your grade change, that's why it changed. Okay, because I had to go and manually in. If I saw, if the answer I expected was lithium, but you put lithium ion, I had to go and manually grade it to give you credit. Okay, so sodium, of course, it remains as sodium. And then if you put ion, either one is correct. Calcium, and then you have calcium. Okay. Now, usually if you're referring to it by itself, we use the term ion to describe iron. But in the context of naming a compound, we don't leave the ion in, we take the ion out. That's why I'm putting this parenthesis here. Usually by itself, you use ion. If you're naming the ion within the compound, the ion word doesn't show up. You just say calcium chloride versus calcium ion chloride. Okay. And of course here, magnesium. And then you got iron here. Once again, may or may not be used. And then we have aluminum. When I came to America, I had to learn aluminum because we learned the British way of writing this, which is aluminium. And I came here and I was like, what? When did the name change? That's one of those things I had to learn. I was like, okay, aluminium to aluminum. Anyway, you adapt. Okay, so this is how you would from the element to the ion. Now remember, the element is not the same thing as the ion, right? The element has no imbalance of charges, the ion does. Even their properties are different. So you can't confuse one for the other. By the way, you can't write Li. This is not the ion. So you have to write Li positive. So in this case, the charge is not implied, right? Li when you mean to say Li positive. The Li positive has to be written as Li positive. And in the notes I wrote for you guys taking the exam, I wrote that there, but of course, sometimes that's not very clear for some people. So in certain cases, like if it is aluminum 3 plus and you write Al, that is very, very wrong, right? It's supposed to be aluminum 3 plus. Anyway, now we're done naming the cations that are monoatomic. So the next thing I want to do is name cations that are polyatomic. And for your naming lab, which is just a handout, they give you these ions, but they're not neatly sorted, right? There's a page there that gives you these polyatomic ions. They're just not neat. So for this part here, I want to see. Let's see. I gave you a few of the monoatomic. Oh, I noticed something. The group I gave you, these are all group A metals, right? Because you see how the ions are just very simple like this. I have to remember holistically. Move to group B metals. Let me name the polyatomic. There are not many. For these, I would say for you guys, I know that you have to remember is ammonium, NH4. See, these are positive ions, but they're made up of more than one. You notice that this time the elements are not metals, right? So these are the ones that break the rule. They are cations, positive ions, but they're not made from metals. So you have NH4 plus and H3O plus. So H3O plus. Okay. These two NH4 plus, it's not an element, so you cannot find it in the periodic table. It is polyatomic. Oh, I just realized the screen is partially obscured. It's polyatomic, right? So this is just named ammonium. Okay. This is the ionic version of the of the compound ammonia. Because I had a student once ask me, how are the two different? They are very different because you have an imbalance of charge. Okay, so to make ammonium, essentially what we had, ammonium is from ammonia, and ammonia has the formula NH3. So it's only 3 hydrogens and no positive charge. Okay, so ammonium is the name of this ion, and it came from that. This one doesn't follow the regular rules, but once again, just recognize this is one of the exceptions to the rules as far as the cations are concerned. These are not metals. You have more than one element to make the cation. The other one we have is H3O plus. Once again, this is called hydronium. If you know the formula of water, it looks like water. So this came from water. And water has the formula H2O, right? So as you can see, from the basic formula of water, you add an additional H and a positive, and that's how you get the hydronium ion. Once again, none of these elements in the hydronium ion are metals. So these are the two cations that are polyatomic that you want to know, that are not necessarily elements, and you can't find them from the periodic table. You find the elements that made up the ions, okay? So I think I'm done with the polyatomic. These two. Now we're going to be looking at, I talked about this briefly on Wednesday when it comes. Let's look at ionic. Ionic B is very similar to the ionic A, right? As in the metals that we're looking at are metals from the from the D and the F. S and P are the ones I looked at here, the lithium, sodium, calcium, magnesium, and aluminum. Fixed charges, lithium will always have a charge +1, sodium always +1, calcium +1, magnesium +3. These never change in charges. So when you're naming them, you just name them as the element and that's it. Now we're looking at cations that have variable charges. Once again, in the page provided for you in your lab. So this is essentially, this session is to help you complete the lab so you're not just Googling the answers. You have some idea on how to complete the lab. So these are cations that have variable charges. And for the most part, they will be monoatomic, right? But these have variable charges. So where do I get these ions? These are metals from the D and F block, or what we call group B metals. Okay, they have more than one charge, so you have to specify the charge. And so I'm going to give you guys a few examples Once again, I'll stick with 5, and I'll stick with the same order I have here, which is element, symbol, name, name, and then ion name. Okay, I have to remember that to kind of keep this sort of organized. Right here, element, symbol again, element, name, ion, symbol, ion, name. Okay, so as we go through this, you can see how this works out. Now, of course, the book has things organized differently, but usually I read the book, but I reorder the notes. So I rewrite my own notes, or I should say I write my own notes and rewrite it until the order of my notes makes sense to me. Okay, and that's essentially what I'm doing right now. So I have an element symbol, element name, ion symbol, ion name. So I'm going to pick random ones because with group B elements, it's not really as simple as it appears. So I'll start with Ti, and then for each I'll provide 2. So let's see, Ti 2 plus, Ti 4 plus. Okay, so this same symbol can form more than one charge. So hopefully as I'm going through this, you're getting that. The next one is going to be ion. Ion 2 plus, ion 3 plus. Let me add a page here. And then let's see, let me go with let me go with, I think you guys did mercury, right? You did mercury as part of the thing. Let me do indium or tin. Tin, tin, I'll do 2 plus here, tin, 4 plus, and I'll do lead, and then lead, 2 plus, and then lead, 4 plus. And I think you get the idea, right? Going through here, that the same symbol from the element can produce various charges. Okay, so this one here is, of course, titanium. This is iron. This is tin. And this is lead. I'll just do 4 for these ones here because it takes up a lot of space. Okay, since you can see each titanium ion can produce, element can produce more than one ion. Imagine you're on the phone talking to somebody. You have to specify which of the 2 are you talking about. So of course here it would be titanium. Ooh, if I can spell. Titanium 2, put the charge in parentheses like that. And then this one here will be titanium 4. So you want to use the Roman symbols for that. The Roman symbol represents the charge that we have up 2 and 4. Here we have iron 2, iron 10, 2. Oh, this is 4. 4. Lead 2. Once again, this is not necessarily part of, but if I don't cover this, then it won't be clear. 4. So you know you're dealing with these B group. Why? Because you have those little Roman numbers right here. Okay. Now remember, these last 2 I use, these are technically group A metals that behave like group B, right? So I mentioned this on Wednesday. Now that I have reviewed this, I want to go ahead and quickly review, because the naming goes a lot faster if you understand how to name the ions. If you don't, then everything I do beyond that, which is building up on this, becomes overwhelming because your brain is still trying to sort through, wait, what was this ion again? Meanwhile, I'm gone and I'm naming all these different things, right? So this foundation part is very important. That's why I call this extra session. Okay. Now that we know how to name cations, now how do we name the anions? So we're moving on now to the anions. With the anions, I'm going to start with the monoatomic, the simple ones. Monoatomic, the ones from the periodic table where you get the charge based on its group position. And these are monoatomic, so these are made from single elements, right? Single elements. That is their source. As usual, let me have my categories here. I'm going to pick, do I even have 5 to pick? 1, 2, 3. I'll pick 4 this time. Okay, so I have the element, symbol, and then element name, then ion symbol, then I'll go with ion name. Okay, so since these are monoatomic and ions, they only, so this is, I won't have many for every element, right? So I'm going to carbon, nitrogen. I'm actually going to go with this nitrogen, oxygen, fluorine. Okay, are my nonmetal. So my symbol carbon, the name of course is carbon. So I'm going to combine certain things because I don't really have a lot of time to go over everything in detail. What I'm going to do here, as I name it, I'm going to underline the part of the name that's the stem word. Remember, if you've taken biology, when they're naming different parts of the body or different critters and stuff, they tend to have certain stem words, right? For example, like if you're dealing with blood, they tend to use the term him, or something like that to refer to blood. So if someone has a blood disease, they say hemophilia or hemoglobin or him. You hear those terms, right? So in this case, the stem word for carbon is carb. And you see the term carb all the time when they're referring to carbon. So carbon here is the stem carb for carbon. Okay. And then for nitrogen, nitra, N-I-T-R, that's the carb, sorry, that's the stem word. For oxygen, oxygen, O-X is the stem word. Remember, fluorine is flowering. So fluor is the stem word. Okay. So I'm just going to highlight the stem words here so you can remember. Okay. In the symbol for the ion, remember the ions for monoatomic, the group number has something to do with it. So here it's usually group number -8, or you look at how many steps it takes for that element to get to 8. So in this case here, wait, give me just a second. Somebody from your class is emailing me. Oh, okay. So carbon, let's see. Carbon is in group 4. Now I told you guys before, the or lose 4 electrons, but there are instances when we see 4. Remember, this one here has to do with its group position. Carbon is in group 4, so it takes 4 more moves to get to 8, right? Nitrogen is in group 5, so it takes 3 moves to get to 8, so 3 minus. Oxygen group 6, O2 minus. Fluorine group 7, fluorine minus. Okay. The charges here, to figure out the charge, just take the group number -8 and you get the charge. So these are the symbols of the ions that could form from the element on the left. Now, how do you name these ion names? The ion names is essentially the stem name, for the most part, this is a rule, then add the term IDE, the suffix IDE. So the stem plus IDE. So the word was what? Carb. Let me go through and write just the stem words. So carb, nitra, ox, fluor, right? Fluor. Okay. So remember, just add the IDE to the stem word. So you got carb, then you have IDE. Nitro, then IDE, nitride. Ox, IED, oxide, fluor, then IDE, fluoride. It's pronounced, fluoride. So once again, don't confuse the element with the ion. The ion is the one that has the imbalance of charge. The behavior usually is very different. The chemical phase even changes when it goes from the element to the ion. Okay. Now, the STEM-ide format is only seen when you have monoatomic elements. When you have polyatomic elements, most of the time we don't have STEM-ide, right? We have STEM-8 and STEM-US. And you guys got to see this. Once again, this is probably, hopefully, it's making more sense because you've already studied for it and did the exam. If you hadn't, all of this would be so even more crazy. When I was taking this class a few years ago, we didn't even go over this. Once we did the test, that was it. Then we named the compounds. And it's like, all the best. Okay, now we're dealing with the polyatomic. Polyatomic meaning, once again, many atoms, right, making up the anions. So in this case, sadly, we don't just have two, we have a bunch. Sadly, I don't have my list here, but I can mix them up. Polyatomic anions. So these are anions from many elements. All are going to be negative, right? So I'm going to pick a few. I'll pick 3, 2 minus. With this one, you can't use the group position to figure out the symbol. So once again, in your lab, there's a page that has all of these. I'm going to pick ones from phosphorus, PO3, 3 minus, PO4, 4, no, it's still 3 minus. What am I thinking? 3 minus. 2 minus, NO3 minus. Oh, let me do the ones that have exceptions. Phosphorus in its nomenclature, and so does, yeah, we'll do that down the road. Let me add one more set, the sulfurs. One more set here, SO3, 2 minus, SO4, 2 minus. So with these, once again, you can't look at the periodic table and then figure these symbols out. These symbols just have to be memorized. They are what they are, okay? The polyatomic a little bit more complicated. The periodic table won't help you in memorizing them. You just have to memorize them. There's no group number from the periodic table. Okay. We had the STEM word. Here are going to have two forms in general. The forms are STEM. Let me write this somewhere here, up here. It's STEM-8 or ite. The STEM-8 name, remember the stems we talk about up here, the ones I mentioned up here? You write the STEM word and you add the ATE in the place of IDE. Oh, come on, people. I'm sorry, guys. This is really, I'm sorry. Sorry. Thank you for letting me know, guys. We'll make this. So, as I was saying, the compound that ends with with 8 has oxygen. So let me write this down just so I can make sure we're on the same page. Let me write this here. Hold on. Give me just a second. ClO negative, ClO2 negative, ClO3 negative, ClO4 negative. Okay. So ion that end with ATE have oxygen in their formula. And this is most of the time, right? Not only do they have oxygen, they have more, this is have more oxygen than the, than a similar ion that ends ITE. So the 8 is related to I. 8 has more oxygen than the I, but how, don't know. We just know that it's more. Okay. So as we go through this, I will do this one last because this set of 4 is very unique. Okay. So I'm going to write the stem words first, like we had before. This is the stem word, and this is the anion name. The stem word for carbon, so you write the stem word for the first element. This is going to be carb. The stem word for phosphorus is phos, like that. Okay. Then this, so I'm writing the stem word for the highlighted element. Again, the stem word for this is going to be phos, for this part. For nitrogen, it's going to be nitra. So you're naming or you're looking at here. And then the anion name is essentially stem 8 or stem ITE, depending on the active number of carbons, right? So with this one here, is the carbonate, this is the only one we have. So this is going to be carbonate, right? Now I wrote the stem term is carb. For the sake of this here, the stem name is slightly modified. So before it was carb, in this context here, it will be carbon. The stem name for certain elements all the time. Down the road, you will see how even phosphorus stem word changes slightly, including sulfur, okay? But back here, it was carb, right? Carbide. It's not carbonide, it's just carbide. Over here, it changes from carb to carbon, so carbonate. And we have two phos here, right? We have the phos on the bottom that has more oxygen, the oxygen will be phosphate. You add the ATE to the phos. The top one will be phosphite. Okay. Looking at this has more oxygen than that. So this would be nitrate. Once again, we added ATE to the one that has more oxygen. And then this would be nitrite, the one that has less oxygen. And then here, bottom one, I didn't say this was sulf in this context here. Sulf. So here, this would be sulfate and then sulfite. Okay. Now, once again, I went over. Oh, come on. What's going on? Hold on. A horrible recording. I may have to record this again because I keep getting bumped off. Yeah, I'm gonna have to try to use what is it? Teams to see if that works better. I don't know if it's my computer. No, this is actually this is Blackboard, so I don't know. Okay, so sulfate, right? Once again, if you can't see, just let me know. Write something and I'll notice. So sulfate. Now I left this group here, this group of four. Now this group of four that we have here, the group 7 oxides, this setup here works also for works for iodine. Okay, you can build the same series for iodine. Let's see what else. I have chloride. It works for also for bromine. I think in your hand they have a set of four for bromine. So in the place of Cl, they have Br. The rules we for bromine, you just apply the same rules: iodine, bromine, and fluorine. Not so much. We don't see fluorine a lot. Okay. So with this one, what I do, I start with the middle two, this middle two here. So in the middle two, the one that has more oxygen will be named with the 8. Okay. So remember, the stem word here is chlor, 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 chlor. Okay. So I start with the middle two. The one that has more oxygen is the chlorate, right? Like usual. The one that has less oxygen is chlorite. Okay. What about this top one and then this bottom one? Okay. The one that's on top with one oxygen has even less oxygen compared to the chlorate. So they bring in a prefix. And this prefix is to communicate even less than what you thought before. As if the ide is not already communicating that, but it's even less than the chlorite. So they use the prefix here, hypochlorite. Okay, so hypo is saying even less than the chlorite. If you've had biology, they use the term hypo to talk about the concentration of the solution, hypotonic, very, very dilute or less concentration versus hypertonic, right? Or even energy or something, hypo energy versus hyper energy. So in the part of the hyper, they don't use the term hyper here, they just use the part per. But the per here communicates X. They use the whole term, the whole prefix hyper, they use per. I don't know why they left the high part out, but that's what they do. Perchlorate. So per here stands for extra oxygen than even the chlorate. That's how I rationalize it. Remember, I told you guys I'm very bad at memorizing. So there has to be some rationale to this, or else my brain is like not relevant. So I trick my brain by having this whole elaborate story behind it, right? The is the term, the prefix that communicates less than. Usually the hyper communicates more than, but they left the hy out and they just retain the per. So perchlorate has more oxygen than chlorate. Chlorate has more oxygen than chlorite. Right has more oxygen than hypochlorite. This is a series, okay? I think as far as naming the common ions, this is the system. So this is kind of my overview. Of course, I didn't touch every ion, but the rules we have applied here, you can extrapolate to all the other ions. And the rules are within chapter 4. It's just not, they don't kind of just focus on the rules. They go around and all over the place, but this is essentially what they're communicating in chapter 4. Now that we have this, now that we've seen this, I want to go ahead, because this was my goal, naming ionic compounds, is for us to see the naming of ionic compounds. We saw this on Wednesday, but I was hoping that we can see it in context. Remember, there are 5 basic nomenclatures that we're doing as we're naming compounds, especially for your lab. The first, so I call this basic formats. Of course, the formats do have exceptions, right? So the first is when we're naming ionic A compounds. Remember the A group, these are the elements that have fixed charges. You will have this template or the format. You have the element name, then you have the anion name. We just reviewed how to name anions, right? So you know how it fits. Second one, ionic B compounds. For the ionic B compounds, as we saw, because ionic B compounds have many charges, you will have an additional entity in the name. You have the element name, you have the charge in parentheses, and you can see why, right? They have many, and then you have the anion. Oops, anion. Okay. Number 3, with molecular compounds. So I'm quickly reviewing what we covered on Wednesday, right? Molecular compounds, you have 4 parts to the name. It's usually 4 unless the first part is mono, then one part is missing, right? So when you're looking at the name, you're looking at the name intently to judge what type of element you're dealing with. You're not just rushing to it, right? So the 4 parts are prefix, and I usually write here, no mono. So if mono is out, or what I write is, I write this here. If it's mono, we don't include mono. So if you feel like it looks like a molecular compound, but the first prefix is left out, that just means that first prefix was mono. Prefix, element, prefix, anion. Okay? So you may have 3 or 4 parts to the name, and if you do, that is most likely molecular compound. Number 4. Number 4, we're dealing with acids. So we will look at this once again. My goal is for us to get through this. I'll call this binary acids. I never got to this at all on Wednesday. Binary acid. With binary acid, this one here, the name tends to have the following: hydro, stemic. Remember the stem names we're talking about today? So hydro, every binary acid begins with the term hydro. Okay, so hydro, like hydrochloric acid, the acid we currently have in our stomach that is digesting the food we had this morning. Hopefully we had breakfast, right? So hydrochlor, and then ic, and then the word acid. Okay, so in naming this, the stem part is the part that's different based on what anion, or sorry, what non-metal you have in the formula. So once again, we'll get into that. And then finally, we have the oxy acid, which we didn't name once again on Wednesday. The oxy, I'm writing oxygen, oxy acid, oxy acid. These acids have oxygens in them. So depending on the kind of polyatomic ion you have, we essentially have 2 templates here. You have the stemic acid or us acid. So this is the summary, the overview of what we're going to be looking at. When it comes to nomenclature, the first 3 will be a review on Wednesday. The last 2 should theoretically be new. Okay, so technically this part is the true 1411 content, but I feel like if we don't go over the common ion part and resolve it, when I'm talking about the anions here, that will be complicated, or even the ones, the cations with the charge, right? That part will be complicated. Okay, so we talked about how to name these on Wednesday. So I want to go over this again and talk about how do we figure out the ionic A, how do we figure out ionic B. I'm not going to discuss the rules for this part here because we already did these 3 on Wednesday. I want to go through your lab. So what I'm going to do here is go through your lab. I thought I had this downloaded. Oh yeah, here, look. Oops. It's gone. We had that. Well, I had that. Okay. Talked about this before. So hopefully you see that here because you do have a lot to do in your lab on this lab right here. Remember we talked about how to identify this. You want to go through and identify what happened to this page. Why won't it allow me to scroll down? Go to and identify as it shows you right here, which is which is ionic A, which is ionic B. Then you name this accordingly. Like, this is the page I was talking to you about, right? They gave you the common polyatomic ions, the nitrate, the nitrite. Everything isn't spelled out, but you see how they had the chlorines, and they show you this works for fluorine, iodine, same as that. So I essentially went over most of this today. Then they have the oxalate here, chromate, all the other extra stuff, permanganate. So these are all here. They've always been here and available to you. Okay, so what I'm going to do here in helping you guys work through this, we did work through a few of these, so I don't want to go over these again. We talked about ionic A's, right? We did this part, ionic A's, identify what was ionic A. Remember, when you are identifying the element or the compound within the element, start with the first element, okay? I went through this and I showed you guys how to figure out ionic A's. Start with the first element. Is it in the A group? Remember, the A group is mostly the S, all of the S, and the top part of the P metals, right? And so we went through here. We said potassium is A, aluminum is A, magnesium is A. Therefore, it makes ionic A, ionic A, ionic A. As you can see here, when I'm naming these, I am following the format. For all the names provided here, potassium sulfide, let me show you how this fits the format. The first element, potassium, is named as a metal. So I have the metal right here, just like I said. The second part here is named as an anion, right? And this is an anion of an individual element, not a group of elements. So it's monoatomic anion. So potassium sulfide, aluminum nitride. These are all following the metal name and then the anion. Remember, the metal is named as an element. Okay, so these are all following that format. And I wanted to be systematic in how I was naming it versus kind of going from one rule to the other. So this is going to be, oh, sorry, I'm talking and writing, so I'm forgetting what I'm trying to write. My brain is not multitasking very well today. Okay, so the format is element and then anion, right, for all of 1A. So for everything here, that's 1A, that's it. Potassium sulfide, element anion. Aluminum nitride, element anion. Magnesium, element anion. The ones I labeled 1B, I have to name those differently, right? Because remember, 1B has the element and charge in an anion. So that's why I named these on Monday. Sorry, last minute. Okay, so my goal is to continue that. Let's see. Now that we're here, I kind of started here and I was like, let's make sure we're good with this one here. Okay, so looking at this right here, we started with sodium phosphate, right? So let's remember, since you guys have the ions memorized, we'll go through this part here. We're still following the same order, which is element, anion. As long as the element is group A, we have to follow that. So we're dealing with ionic A compound, element and ion. So our element here, which is essentially the metal, is sodium. You name it as sodium. Our anion is PO4. And then this 3 goes with the PO4. Even though our formula is Na3PO4, this 3 came from phosphate. So the 3 in front of sodium is really communicating to a neutral compound. We need 3 sodium ions. Remember here, right? Sodium is originally Na plus. Phosphate is originally PO4 3 minus to get the compound that they had here. Because when you're looking at this compound, what you're technically seeing is the end. Then the question you want to ask is, well, how do we get here? This 3 came from phosphate. So this 3 that's down here, put it back on phosphate. And then please realize, for the most part, the first symbol written is positive. When you're dealing with ionic compounds, for those of you who weren't here on Wednesday, this I, or what looks like a 1, is ionic, right? So this is ionic A, ionic B, ionic A, ionic A, ionic B. That's what the I stands for, just in case, to kind of catch you up. We have judged all of these as ionic compounds. How do we know that? Ionic compounds, also to catch you up, are essentially metals for the most part and non-metals. So what we're trying to say, the first element each time is a metal. Potassium is a metal, copper is a metal, aluminum is a metal, magnesium, manganese, sodium, potassium, chromium, zinc, tin. All of these are metals, followed by nonmetals. So we have judged these all as ionic and then labeled them as either A or B. Okay, so that's me quickly catching. So ionic metals start with the positive ion first, this positive, the negative ion second. Okay, and then when you crisscross them to get this compound, the positive essentially lands in the bottom. So you end up with the 3 from the phosphate down here, and then positive 1 in the phosphate. But in chemistry, since this positive 1 is here and there's only 1, we don't need the parentheses. So they actually leave this part here out. So it looks like that. So this is sodium phosphate. So you just name the metal, name the metal as an element, name the anion as an anion, and that's how we get the name right here. Do the same thing for the next one. We got K, M, N, O, 4. There is nothing down here, right? There's nothing, and there's nothing down here. If it's nothing down here, remember that you need to know the charge of potassium. Potassium is in group 1, so its charge is positive. That makes this negative. So positive 1, negative 1. What's the name of this? Name potassium like an element. So right here, potassium. This one here, this has a unique name. Did they have the somewhere here? MnO4. They gave you the name of it. I saw this earlier. MnO4. Maybe it wasn't here. Oh, there it is. Permanganate. So even though I didn't give that to you, the name of MnO4 minus is permanganate. So this is going to be per. That means we have a lot of oxygen, right? Because per means a lot. Manganate. When I was learning these, I will pronounce each vowel out, because we got points taken off for right. So this was permanganate, permanganate, right? These are ionic A. They all follow the same format. Now remember, the per here is not a prefix communicating the number of elements, just about the oxygen, right? And then we go through all of these. So the rest of these, oh, this one is ionic A star star, ionic B. Yeah. So with ionic B, I mentioned this to you guys here, that remember zinc is it's a B element, but you name it like it was an A element, right? Because zinc doesn't have more than one charge, so it also needs 2 names. That's it, no number. So even though it's ionic B, you can name it with the ionic A. Okay, first element here will be zinc. Okay, now zinc normally has a charge, so I'm going to add it here so you can see how it follows the format. Zinc normally has a charge of 2 plus. And if you look at sulfate, I already told you what sulfate was. Sulfate is 2 minus. just in case you're forgotten since you learned this last week, it should be somewhere here. Look for the sulfurs. There, sulfate has a charge of 2 minus. Okay, so if it shows that you need one of each to make a neutral compound, that means if sulfate is 2 minus, zinc is 2 plus, and they kind of cancel each other out. So in the compound, you just need one of each to make a neutral. The name of this is zinc for this, and then this is called sulfate. Okay. I think we have named all the chemicals that follow the format of the ionic A compound, element and ion, right? All the way through. So the next group we're going to be looking at here is element, charge, and ion. I want to look at those together so y'all can see how this works out. As I said, the naming is not easy. People look at naming and say, oh, this will be easy. No. For me, because I'm not good with words, my brain just has this thing about words. It's just my brain is random. If I learn something one way, it regurgitates it back to me in a very different random way. So it's hard for me to recall things for word, making recall very difficult for me. I mean, I'll spend time memorizing my brain to recall it different. So I usually have to write things down from trying to force my brain into. Okay, so now we're okay. For that reason, to force my brain into compliance, I have a very systematic way of learning things, okay, which is to do the same thing over and over again to force my brain to focus. So we're now working on B. The B group, you name it as element. Okay, this is the format, char, and then anion. So you will notice all of these are following that format, elements, char, and this is how we name ionic B metals. These are the ones that have so many charges, so you have to specify which charge we're dealing with. Okay, so first one we're looking at here is the symbol copper, and it says 2 oxygen. So we remember this charge belongs to the first element, right? We need the charge on the first element. Well, that part is kind of tricky because what is the charge in the first element? Okay, I'm trying to make sure this thing is still working. Okay, what's the charge in the first element? Do the reverse crisscross. It's like a dance, reverse crisscross. Bring this 2 back to the oxygen. And then whatever number is here, remember, if it's nothing, that means it's just 1. Bring this back to carbon, and then we get the charge of the first element. Remember, the first one being positive. When I bring this back, I essentially end up with copper, positive, oxygen, 2, negative. Remember, in ionic compound, the first element is always positive, the second element is always negative. Okay? Positive, positive 1. Okay, we can say 1 positive. Oxygen is 2 negative. So when I'm looking at my name here, this is a format. This one will be named as an element. I'm just going to write it here. Copper. Oh, let me write over here. Sorry. Copper, right? That's the one that's going to be named like an element. And then the charge is the charge of that element. In my structure here, copper is 1. So I have to put parentheses 1. You can write it like that, or you can put this like this, because it's technically Roman numbers, right? So this is I, you can put it like that. So copper 1, copper, and then this charge. And then they say name the second one as an anion. When oxygen is -2, what's the name of this anion? We just learned that today, right? We relearned it today, I should say. Oxide. Okay, so copper 1 oxide. I named this like an element. I included the charge. And then the second one is an anion. So you see the nomenclature, how different it is. It's not that different, but it's significantly you can visually tell, right? This is supposed to be I. They put 1. Haha. It's MNI2. Okay, I'm going to do the same thing with that one. Yeah, I'm essentially helping you get the answers for your lab, but I'm trying to also teach you as I help you guys with this, right? Because I said it's not really that easy. So when I'm given any kind of assignment where these are mixed up, I sort them because y'all, I've made peace with the brain I have. I know how my brain can be helpful and can be unhelpful. If I do this out of order, I mess up, not because I don't know. My brain just, it's just not the best way for my brain. Okay, so I have to do them in order. MnI2. Mn, let's see, just like before, I have to write my formula out and crisscross, right? I2. Because I know the element's name. I need the charge of Mn though. So I'm going to crisscross this, bring this back up here. And then the one that used to be here that got dropped off, bring this back here. Make the Mn positive, right? The 2 came back here and became 2 positive. You can write it as positive 2 or 2. Then I is going to be 1 negative. You can even leave it as negative. Name this an element, right? So this is going to be manganese. Is it? Manganese, right? So I fulfill this part of the element, and I need the charge. This is this charge here, 2, right? So I'm done with these first 2. I name the last one as an anion. I minus is essentially iodide. Yeah, that's what they call it, systematic. That means a lot of work. Code for a lot of work, right? Okay, first part. These last 2, guys, we can do this. Just follow the system, follow the order of nomenclature. I'm not gonna combine it with the back yet because that's like a whole. So this one here. Now we're looking at CrOH, the whole thing, parentheses. So once again, bring this 3 back here to Cr. Make it positive. The nothingness here means 1. Bring this back all the way here, make it negative. So this becomes Cr3 plus, right? The whole OH together as a package deal, negative. That's what the parentheses here mean. Okay, so same thing. Name Cr as an element, Cr chromium. Chromium. You see how you still have to memorize these, right? Because even though I'm working out the system, I still have these memorized. Chromium, that's the name of this. It's charge right here. Open parentheses. 3. What's the name of this? This has to be named as an anion. Okay, as an anion, remember it, or you go to this list. I think it's in the list right here, or maybe not. Oh, there, I saw it. Hydroxide. So OH as an anion is hydroxide. Okay. So this is how the common ion you guys learned applies to naming compounds. Last one. This one here, SN, you get the idea, right? This would be 4 positive. This would be negative. So I'm going to do a shorthand here. This would be SN4 positive. This is 10 for NO2 minus. This is going to be nitrite. Because it's not, ooh, nitrite, right? And 4 nitrite. Okay. Now, I did this part here on Tuesday also. If you're, no, sorry, I mean Wednesday. On Wednesday also, you all remember, for this part here, we did talk about how to name the nonmetals. And I said, you're going to go with the prefix, and then element, and then prefix, and then the anion, right? So I'm following that same format. Now, before I do this part, I quickly want to talk about what just happened here. No, we'll look at that later on. I want to talk about the prefixes here. So let me see, how am I doing? I think I'm doing good. I talked about all of these part here. Yeah, so as far as my goals are concerned, I think I'm down here. Not bad at all. Okay, so prefix for the numbers, right? Once again, these are in your PowerPoint. I'm just trying to look at them back to back, like binging on nomenclature versus looking at them the way the PowerPoint presents it. So these are the prefixes for a number of atoms. So real quick, for mono just means one, right? Di is two, tri is three, tetra is four, penta is five, hexa is six, hepta is seven, octa is eight, nona is nine. Some people call their grandma Nona. They're essentially calling her nine. And then deca is 10, right? And so I kind of mentioned this on Monday that if, let's say this is, after I've given you guys the prefixes, right? You can see a majority of these prefixes either end with A or O. When you're naming nonmetals, like I said, when you're naming molecular compounds, we are going to be following the order of prefix, as you just saw, element, prefix, and then anion. Remember, the first one, if the first one is supposed to be mono, we will not include it. So we'll say no to the first one if the first one is mono. We will just leave it out. It will be implied. The other thing I mentioned on Wednesday that I want to mention again is, oh, come on. Okay, so prefix, element, right? So here we don't include mono. The other one is if your anion, if anion is oxide, right? So this scenario applies if your anion is oxide and your prefix ends with an O or an A, you have to consolidate. So if anion is oxide and your prefix, say your prefix is mono, and then you have monoxide, this consolidates into monoxide. So monoxide will be monoxide. And then say you have pentaoxide, because your prefix is saying 5 oxygen, you will use pentoxide in its place. Okay? So if you have decaoxide, you will use decoxide in its place. Okay? So these are the pre-rules to the rules before we start working on these. We don't use mono in the beginning of a molecular compound. We consolidate the prefixes that end with O or with A. So the ones that get consolidated, if you have a situation with the oxide, are all of these that end with A before the oxide. So we don't have heptaoxide, we have heptoxide. We don't have tetraoxide, we have tetroxide. I know. If you're going into organic chemistry, man, they just remix it over there. Tetroxide, pentoxide, hexoxide, heptoxide, octoxide. I know it sounds crazy. So this is what we are following, okay? Now back here. 4 parts to the name: prefix, element, prefix, and ion. Okay. So we start with this. Now remember, the prefix tells you the number of elements. So for my first one, I have 1s and I have 4 f's, right? These are not ionic compounds. I should have led with that. Okay, real quick, rewind. These are, right? These are not ionic compounds. So I should go through and label them. These are all molecular. How do we know? Molecular compounds tend to have the following property. You have non-metal, molecular. Sulfur is a non-metal, fluorine is a non-metal. Oh, is non-metal, and nonmetal. So this is molecular, phosphorus is molecular, chlorine, nonmetal, sulfur, nonmetal, phosphorus again, nonmetal. So these are all molecular compounds. They are not ionic. So the format of nomenclature looks completely different. It will be prefix, element, prefix, anion. This is supposed to be O, okay? And then eventually, when we get to it, these will all be acid, 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 because you see they start with H's, okay? My goal is to get at least down here. Then y'all, since I helped you all with that first page, y'all will be on your own for this part right here, okay? I believe you can do it. Okay, where was I? Right here, this is, oh, it's just one S, right? One sulfur. So remember, one sulfur. Mono is one. Cancel it out, don't worry. Mono, the first one, so I'm done with this part. Prefix, element. Sulfur, sulfur. Okay? And then the other prefix, 4. Tetra. This is not oxide, so I don't have to consolidate anything. Name the remaining F as an anion. Fluoride, right? But the mono here has to be canceled out because we don't. So this would be sulfur tetra. I think I have to reset my computer. Tetra fluoride. Oh, come on, computer, work with me. Okay. Let me see if I can just copy these into the page on my iPad. The app seems to respond a lot more quickly than this, so it's a little bit hard for me to write here. So let me try to copy this over, which I think I should be able to do that. So 11 was SF4. 12 is P4O6. 13 is Cl2O. 14 is SO3. And then 15 is PCl5. Okay, so let me move to the app. The app is responding a lot better. So once again, format, prefix, element. So remember, with the prefix, we don't include mono. Element, then prefix, and ion. Yeah, so much better than writing with my mouse. Okay. I just said this is going to be sulfur. Oh, no, there's no E. Sulfur tetrafluoride for my first one, right? Second one, this is not 1, this is 4. So tetra for my prefix. Phosphorus for my element. That's P. Hexa. Oh, I need to, because you see, I have oxygen here. So hexa oxide, which gets rewritten as hex oxide. Because remember, hexa, the A and the O get consolidated, so it's hex oxide. Because hexa stands for 6. 4 phosphorus, 6 oxides. Okay, next one. This 2 belongs to chlorine, saying 2 chlorines. So prefix, the 2 is di. Chlorine is chlorine because it has to be as an element, right? And then the second prefix, we're going to use anything we need. This is 1, so it's going to be mono, right? And then oxygen is going to be an anion, so oxide. But remember, we consolidate this and it becomes oxide. So we're still following that format. And then here, 14, sulfur. Oh, skip that part because no mono. Sulfur 3 tri oxygen oxide because it has to be named as an anion. You see how I have the format there as an anchor to remind me of what the format is? This is skip the mono. Go straight to phosphorus. Name that phosphorus as an element. And then there's 5. 5 is penta. And then Cl, chloride. Okay, so I named that set. Okay, so you see in all of this, in the name, I am following the format required for molecular compounds. You see how this format is very different from when we're naming ionic compounds. Ionic compounds don't have these kind of prefixes talking about a number. So remember, the prefixes are used for molecular compounds. These prefixes, the hexa, tri, whatever, penta, are used for molecular compounds, not ionic compounds. I know I've been going on and on. Does anybody have any questions about this? Okay. The last part I'm going to let you guys go and I go to my meeting is acids and bases. So I'm going to stick with the handout because it's a lot easier than when I get done. I'm going to actually name the last 5 we have over here. With the acids and bases, the format is this. Remember, if you're still thinking about your question and you're formulating it, feel free to just write it in the chat and I'll look at it. So our last list is the acid and base. Well, just acid, sorry for right now, this part here. So we're going to be naming 16, oops, right here, 16 H2S, 17 HNO3, 18 HI, 19 H3PO, 20 H2CO3. Okay, we can do this. So what I'm going to do before we do this naming of this, I want to review acids, a few acids. So let me go back to my iPad right here. When we're naming acids, we name the polyatomic anions first. So the oxy acids first. How can you tell you have an oxy acid? The oxy acid is acid with oxygen. So that's the one where you're looking at the polyatomic ion first, naming that, then naming the acid. Okay, so oxy acids, these are acids with oxygen in the formula. So polyatomic ions, we'll go over carbonate. I'll do the nitrate, nitrite. And then I'll do the phosphate, the phosphate. And I'll do the sulfite. Okay, I think this will give us enough practice, right? Here are my polyatomic ions. These are it. So we're going to be naming these and modifying the names. For the ones that I've given you little stars on them, modify the names a little bit to this new part. So here, let me do this right here and make it easier for me to follow along. I'm writing this. Okay. So name of ion, we'll name that first. And then formula of the acid. And I'll show you how we get that, the name of acid. Will I even have room for the name of the acid? Okay, hold on. Let me make this a little skinnier so we can see, okay? So once we name this, and it will help us to do the other part. I'm doing this part because it's a little bit more involved. And then the formula of acid and acid name. Okay, I have to go, even though I named this before, I have to go through and rename this. Let me see, can I make this bigger? Okay, I have to go through This was carbonate, right? I named this earlier. This is more oxygen than that, so nitrate. This is nitrite, right? One less oxygen. Two, this is more oxygen, so phosphate, phosphite, and oops, I'll make this less oxygen. Sulfite, sulfate. Okay, so here's the thing. In order for us, before we get the acid, I want to talk about the name and the stem names. So these are the stem names. So modified stem names. That's what I'll call them. Modified stem names. When you're naming the acid, these two have to be modified. The sulfur has to be modified, and so does the phosphorus. Sulfur goes from being sulf as the stem name to sulfur. This is in acids. We use this in acids. We use this in anions. Phosphorus goes from phosphor, or sorry, phosp to phosphor. Okay, so phosphorus goes from phosp to phosphor. Sulfur goes from sulf to sulfur. When we're dealing with acids, we will elongate the stem word because that's what scientists did. Why? I don't know. They just changed the name. I'm like, why can't you all stick with the original one? It makes me wonder about their minds too. I think their minds is kind of like my mind. Anyway, modified stem names. Okay, and then to make acid, add as many H hydrogen ions needed to make neutral compound. This is what I'm about to do, right? Okay, add as many H plus needed to make neutral compound. So for each acid, I'm going to just add as many H plus needed. Let me give you an example here how I'm going to do it. You can use the crisscross method and say H plus is going to be combined with phosphate, like that. Well, how many H pluses does it require to neutralize PO4? You can say it takes 3 H's, right? Because each of them will be H plus times 3 plus to neutralize PO4 3 minus. Or you can use the crisscross method. Either one works. 3 minus. This positive comes down here. This 3 comes down here. And we end up with, it takes 3 hydrogens, you see, and 1 phosphate to make a neutral compound. So I'm going to stick with this idea more, okay? Depending on the negative charge here, I'm going to add a hydrogen per negative charge to make the compound. So what I mean by that is starting with this, since I have 2 negatives here to make the compound, I'm going to crisscross with this and I end up with 2 hydrogens and then this, okay? Or you can say it was like this, CO3 2 minus, the 2 came down here and that's how I got that. Here I have 1 negative, so it's going to be HNO3. Here I have 1 negative, HNO2. Here I have 3 negatives, so H3PO3. 3 negatives, H3PO4. 2 negatives, remember this is the part that's determining how many H's I pick. And this is going to be H2SO3, H2SO4. Now the nomenclature that will finish up this part, and so you can go ahead and work on your lab. This will be, this last part. How do we actually name the acid? You take the suffix ate and replace it with ic acid. Take ate, replace it with ic acid. So to name this acid, I'll say here, replace ATE with ic and then the word acid. Replace ITE with OUS, acid. So for the simple ones, I'll start with those. Oh, I used the name of I used the space here. I'm sorry, guys. Go ahead and copy that. 8 is replaced with ic acid. Ite is replaced with us acid. So when I was learning this in school, man, I was pacing down, up and down the hallway. I realized for me to force my brain to operate at a higher level, sometimes I have to pace. Just I think it's the activation with my legs. When I'm walking around and I'm pacing, it really helps me to recall, right? To learn things I have to memorize. I don't know why. When it comes to logic, man, I can be sitting down, laying back. I'm like, yeah, that makes sense. But memorizing stuff, ooh, even though in Bloom's taxonomy, that's the lowest thing, for me, for my brain, it's harder. So I was pacing, saying, 8 becomes ic acid. What? I becomes us acid. Like, what are you doing? Leave me A in this class. Those days, the good old days. I mean, the different old days, right? There was no Rona. Okay, so carbonate becomes carbon. Take the 8 out. Carbonic acid. Carbonic acid. Okay. And then what used to be nitrate, ATE, becomes nitric acid. Replace the ATE with ic acid. And then nitrite becomes nitrous acid. Okay. So remember, I mentioned this down here. Sulfur, you have to elongate the stem word when you're naming the acid. And phosphorus, you have to elongate the stem word. I'm about to do that right now so y'all can see. Named as an anion, it used to be. Wait, did something happen again? Oh, okay, I thought something happened. Okay, with the anion. Yeah, sorry, I know I'm going long. Sorry, I just need to finish this part. With the anion here, we have phosphite, right? So you need to elongate the name before you replace the prefix. So this becomes phosphor, right? Replacing this prefix. And the ITE is replaced with OUS, acid. So this is called phosphorus acid. And then phosphate. So in this case, once again, both parts are replaced. Phos is replaced with phosphor, and then the ATE is replaced with ic acid, phosphoric acid. Sulfite, and then sulfate. For sulfide, the sulf is replaced with sulfur. Then the ITE is replaced with OUS, acid. Here, sulf is replaced with sulfur, and then ATE is replaced with ic acid. So we have sulfurous acid, sulfuric acid. You probably have heard about these, right? You just didn't realize, man, it took so much to name these. When I just, it took so much to name these. So knowing what kind of make a difference. I harder one so we can finish with the easier one. I didn't say harder, right? I meant harder. This is the harder one. So notice the name. What is the format of the name? We have the stem word, OUS acid, or the stem word, ic acid, stem us, or stem ic acid. Okay? So let's go back to our list that we had up here. We're going to be using this format for the oxy acid, either stem OUS acid or stem IC acid. Okay, stem ic or stem us acid. Now remember, we named this first. This is nitrate as an ion. Then replace the 8 with ic acid. So this becomes nitric acid. That's the name of this acid. I'm only picking the oxy acids, right? So I'll call this oxy, this oxy, this oxy. This is also oxy. In naming this anion, this is called phosphite. Remember, you want to elongate this so it becomes phosphor. Then replace ITE with OUS, phosphorus acid. So the name for this is going to be, of course, phosphorus acid. Okay. This one here, you're naming the anion carbonate. This one doesn't have to be elongated, so replace the H with the ic acid. That's it. So it becomes carbonic acid. Okay. So I have named 17 in your lab, 19 and 20. I left the easier one for last. When you're naming the binary acid, or the remaining, these are called binary because they're mostly elements. Okay. With binary acid, relatively, right? Binary acid, the format is hydro, the first element, but the first element is named, the hydro represents hydrogen. This one here represents hydrogen. I'm getting these emails that are distracting me. And then the element is named as M. So hydro, stem, ic, and then acid. Oops, acid. Okay. So hydro represents hydrogen. Stem here is other non-metal. And then you add ic acid. Okay. I'm going to give you examples of that before we go to, because we don't have a lot of practice in our actual lab. I'm going to give you examples of these binary acids. Example of these acids are going to be H3P, H3AS, H2S, H2SE, HI. So we're going to follow this format, right? Hydro, stem, ic, acid. So I guarantee you all of these start with the word hydro. Hydro, hydro, hydro. And I've judged them all as binary, right? So I'll call them B for binary, B for binary, B for binary, B for binary, B for binary. Why? All these acids start with H, and then you have another element. So H and something else, and they're all H and another nonmetal. So the format, if you're wondering, for binary acid is hydrogen and a nonmetal. So H that, H this, H that, HI. And then hydro, right? They're all starting with hydro. So I'm done with this part. Now to find the stem word that works for this nonmetal. For acids, remember phosphorus for acid is going to be phosphor for phosphorus. AS, what's AS again? Arsenic, arsen. And then I'm trying to just follow the format here, right? So phosphor, arsen, and then what is this? S is modified sulfur. Se is selene. I is iod. So I got the stem word for all of these second nonmetals right here, if they were in an acid. Okay. Then I have ic acid. Okay. So hydrophosphoric acid, hydroarsenic acid. If it forms this kind of acid, I'm just following the format. Hydrosulfuric acid, hydrosalinic acid, hydroiodic acid. Okay? Once again, I'm following the format. Hydro is the mandatory word. Don't confuse hydro with hypo. So hydro is not the same as hypo. Not the same. Hydrostamic acid. So all binary acids have that format. Hydrostamic acid. Now that you have seen that, once again, the great thing about video is you can always rewind, right? Feel free to rewind as you watch this. Hydrosalinic acid, hydrophosphoric acid, hydroarsenic acid. As we're going through all this, I'm following the format. Now let's use that understanding to name the last two on that one page. Once again, for binary acids, so binary meaning two element acid, my format is going to be hydrostamic acid. So I have kind of these small name, right? So I can say here this starts with hydro. So does this one here, hydro. They're both stem word for S. Ooh, the modified one, sulfur. Stem word for iod. And then I have to add ic acid. Ic acid. I add ic acid here, ic acid, and I am done with that page. Okay. So y'all can go through and then work on the rest. It will seem like tedious, but the point is for you to learn the rules so that even though when you're listening to me, you're like, oh, I've memorized it. No, I haven't memorized this. I mean, I remember it, but the process by which I remember it is different from people who just memorize stuff. Okay, so yeah, in the end, that we all meet the same goal, but our process is very different. Okay, I tend to write a lot because that also helps me to recall the information. But this is all I have for today. This whole section today was about naming. So please work on that lab, complete that lab. If you still have questions about it, send me email. I know it's going to be spring break, whatever that is. Complete that lab if you haven't completed it. As you're working on it, use this chance to learn this. If you still have questions about naming something, just ask me and then send me emails and I'll go ahead and respond. Okay? Have a nice break. Unless you have any question, then go ahead and in the message box. Okay, you're welcome. Bye.